Example 2. A stone thrown vertically. Suppose a stone is thrown vertically upward from the edge of the cliff with an initial velocity of 64 feet per second from a height of 32 feet above the ground. The height s in feet of the stone above the ground t seconds after it is thrown is s equals negative 16t squared plus 64t plus 32. Part A. Determine the velocity v and the acceleration a of the stone after t seconds. Because the velocity v is the first derivative of the position function, and the acceleration is the first derivative of the velocity or the second derivative of the position function. As position function s equals negative 16t squared plus 64t plus 32, the first derivative or the velocity would be negative 16. Applying the power rule would be 2 times t plus 64 plus 0, or rewrite it as negative 32t plus 64, and the unit is feet per second. For the acceleration, which is the first derivative of the velocity or the second derivative of the position, so we find another derivative or the derivative of negative 32t plus 64 to get negative 32. The unit is feet per second squared. In part B, when does the stone reach its highest point? The highest point, that means the velocity is 0 because the stone is going upward and then reach the highest point, it's coming back down. At the top or at the maximum height, the velocity is 0. Or we can use the graphical way as the maximum point has the horizontal tangent line, or the v equals 0, which is the s prime. So we are going to find the point of the time where v equals 0. And from part A, we have v equals negative 32t plus 64. Let it be 0, and then solve for t. We have 32t equals 64, or t equals 2. The unit is in second. So it takes 2 seconds to reach its maximum height or the highest point. Part C, what is the height of the stone at the highest point? In part B, we get the time t equals 2 when it reached the maximum height. So at t equals 2, we're going to find the height for s at 2 equals negative 16, 2 to the second, plus 64 times 2 plus 32. Let's simplify the number to get 96 feet. Part D, when does the stone strike the ground? The key term, strike the ground, that means the position for s at t equals 0. The stone go up and come back to the ground. As for the time or t, so we set s equals 0. Our s is negative 16 t squared plus 64 times t plus 32 equals 0. And we are going to solve this quadratic equation. First of all, divide all by negative 16 to get the equation in the form of t squared minus 4t minus 2 equals 0, and use the quadratic formula, or you can do the completing the squared if you like. So for the quadratic formula, t equals negative b, which is negative 4, or t, let's write on the side here. Negative b plus minus square root of b squared minus 4ac, all divided by 2a, where a is 1, b is negative 4, and c is negative 2 for this equation. Then t equals 4 plus minus square root of 4 squared minus 4 times 1 times negative 2, all divided by 2 times a, which is 2. Simplify the numbers to get 2 plus minus square root 6, or we get the number 4.45 and negative 0.45. For the application problem, t has to be greater than or equal to 0. So our answer is t equals 4.45 seconds. Disregard the negative number. So it takes 4.45 seconds to strike the ground. Part E. With what velocity does the stone strike the ground? We use the time that we found in part D. So at t equals 4.45, we're going to find the velocity, which is the v. So v at 4.45 equals negative 32 times 4.45 plus 64. And the answer is negative 78.4. The unit is feet per second. Negative side, that means the direction of the stone is in the opposite way, or it's coming back to the ground. If you sketch the graph, since the s function, s of t equals negative 16t squared plus 64t plus 32. The intercept is 32, and this is a parabola, opens down. The horizontal axis is the t, the vertical axis is the position or the height above the ground. It reaches the maximum height at t equals 2, and it strikes the ground at t equals 4.45, and at this point, the slope, which is the velocity at the point that it comes back to the ground, or the slope of the tangent line, the v, which is s prime, is negative 78.4.